make the most of this time. So
Uh,
this problem here, when you're factoring, you're looking for two numbers that multiply to the last number, but add to the middle number. So you're looking for two numbers that multiply to 6, but then
that make
add to
up.
7. And for whatever
So
reason,
that'd be like,
yeah.
oh, it's 7 and like -1 or something like that.
Well, see, that's what I don't understand. So students seem to focus on this addition part, but there's actually an infinite number of numbers that add to 7.
Uh-huh.
So you really want to focus on the multiplication part.
Um, 1 and 6.
Okay. And then 2 and 3. Do either of those add to 7?
Yes, 1 and
Yes.
6.
So this becomes x plus 1, x plus 6.
And then you're basically just done with that, correct?
That's it. That's all they're looking for there. So for number 3, it's the same idea here. Two numbers that multiply to 12, but add to 7. And you got to focus on the multiplication first.
Um, 3 and 4.
Okay, so it becomes x plus 3, x plus
X
4.
plus 4.
All right, so why don't you try number 4 on your own, and we'll talk about 5. 5 is a little bit different.
X plus 12, x plus 2.
Yes. All right, so number 5 starts a new sequence of problems. There's actually 3 types that are taught in Algebra 1. So now you're looking for two numbers that multiply to -24, but add to 10. Okay, so this is where students tend to struggle the most because they don't want to list out all of the possibilities. And one is positive and one is negative. And you don't know which
Yeah.
one it is until you write all the possibilities out. And I would want you to do this as a student. Most students don't do this, but I would want you to. And then
Uh-huh.
you will find the one that adds to positive 10.
So then that would be -2 plus 12. So x minus 2, x plus 12.
Yes. Now, you don't have to make this list. That is not required. It's not even part, it may not even be partial credit. What is required is that you come up with the right numbers.
Like, do
And
you recommend writing out the whole list?
absolutely, but it's hard. It's hard because you have to be disciplined to do this. If you do it,
Oh,
you will always get the answer.
that's true.
What happens is students don't do it, or they come up with numbers that work for one but not both. And then they say, oh, it doesn't have a solution, but these all have a solution.
Uh-huh. Yeah, I don't think any of my problems will be no solution. Um, so for 6,
Two numbers that multiply to -12, but add to +4.
-2 plus 6.
Okay,
And
x
then
minus 2.
x minus 2, x plus 6.
Good. All right, so why don't you try the next 3 or 4 here? 7, 8, 9, 10. So maybe try those. Just work through those and let me know what you
Alright.
come up with.
Negative x is referring to like -1, correct?
Exactly, yeah.
Okay. For 7, it would be x plus 3 and x minus 4,
Okay,
and
that
also
works.
do an 8. For 8, it would be x plus 4 and x minus 6.
And the order doesn't matter. Like if you said x minus 6, x plus 4, that would be okay as well.
Uh-huh. Okay, I'm just doing it in order, I guess, just to keep my
Yeah,
facts
however
straight.
you're doing, it's fine. Keep going.
X plus 2 and x minus 8 for number 9.
Okay, very good.
And then, so if it's 0x, x minus 4 and x plus 4.
Yes, very good. So the last one there transitions to what's called difference of squares, which has a certain formula for 11 and 12. Let me
Sorry, could you repeat that? I like didn't hear that.
yeah, the 10 transitions to this formula for what's called difference of squares,
Uh-huh.
which is a special type of factoring. It's got this formula a squared minus b squared, which equals a minus b, a plus b. It's a special case. You're going to see that you have two terms when you do this. Now, the other way to do it is to look at a problem like 11 and see it as x squared plus 0x minus 25. But ultimately, you don't really want to do that. You want to recognize that it's difference of squares, and you have to figure out what a is and what b is. Have you seen this before, or is this totally new?
I believe I've seen this before.
So a is the thing that when you square it gets you back to x squared. So in your problem, it's like your a is x and your b is 5 because 5 squared gets you to 25. X squared gets you back to x squared.
X squared minus 5 squared. X squared minus 7 squared. Is that
Right.
basically
So,
like the rundown of it? Just kind of
well,
square it?
well, kind of, yeah, it does get a little more complicated, but like a is the x and b is the 5. So what
Mhm.
goes in parentheses?
Um, A is the X, B is the 5. So X and 5?
What goes in parentheses? Yeah, I mean, what's the a
Oh,
minus b, a plus b? What are we gonna put in here?
X minus 5, X minus 5.
They can't both be negative.
Oh, positive because there's a negative at the end. So one has to be negative, one has to be positive.
Okay.
And
All right.
then
About
for the other
12.
one, it would be X minus 7, X plus 7.
Okay, great. Now 13 and 14 get back to the problem that you were doing earlier, which is you're trying to find two numbers that multiply to the last. So for 13, it's multiply to 24, but add to negative 10.
So X to 24 and add it to negative 10. So, oh, okay, yeah. So that'd be X plus 2 minus 10.
Got to multiply to 24,
Oh, yeah, like
positive
2
24.
and 2 and 12. So it's like,
Okay. So how does that work? 'Cause that does not add to negative 10.
um,
Is there any other way to get
oh,
to,
6 and 4.
okay, do those add to negative 10?
If you make one of them negative.
More than that?
Um, one positive, one negative, or
What's the pattern that you're seeing here?
um, there's a positive, negative, positive, negative.
They're either both positive or both negative.
Oh, so maybe like -4, -6 would get us some
That's,
-10.
there you go.
So in this case, it wouldn't just make it a positive.
Well, two negatives multiply together to make a positive, and they
Oh,
add to make the negative.
which is positive 24 in that scenario.
Yeah. Yeah.
Okay, that makes more sense now, actually. So then I guess for the one below, -1, -12, x
There you
minus
go.
1, x minus 12.
Okay. Good job on that. Okay. So this next page, let's exit ticket. Probably be good for you to run through these 1 through 14. Maybe you already did. No, we already did that.
J Is it just an
Yeah.
empty page that I sent you?
No, they did your teacher just repeated all the problems or whatever. I already did all those.
Yeah.
So
Yeah,
let me put a few more up in front of you to try. And make these a little more difficult. All right, so here's your first one to try.
to make it to be 1.
Yeah, positive one. Yep.
Hmm. Yeah, I'm gonna be honest, I don't know.
So this is this classic problem, right? If you follow just writing down all the possibilities, and I'm not going to go much past this because this really
Uh-huh.
is for you to try. You will eventually find the answer. Like you're giving up way too soon.
Okay.
And when you find the answer, you're gonna say, "Oh, I should have recognized that."
Alright, I'll keep going through that then right now. Is 4 22.5?
It has to go in perfectly, whole numbers, so no fractions, no integers.
So I should just go from 3 to 5?
Yeah, if it doesn't work, then
Oh, yeah, 9 and 10.
So here's what you said, but that doesn't match up to the pattern here. Uh, Meaning
Minus,
like which one's positive and one's negative? Which one?
um, it would have to be -9 and +10.
Yes. Okay. What do you think about that?
I
Why
definitely
was that? And why was that? Do you think that why was that one so difficult?
because I had it was a big number that it wasn't just easy to, like,
Exactly.
simplify
Exactly.
right away.
All right. So here's another one for you to try.
K -5 and, uh, -8.
Very good. Okay. Let's see what else you had here. So there's a bunch of other types of factorings that will get in. You will get into. Have you studied any other than this type?
Um, I don't believe so, just, like, I sent you pictures, um, of, like, a Google slideshow
Okay.
in that email, and that's what we were doing today in class.
Okay. So we're gonna look at some the next type, which is the most difficult for most students here. Let me grab some here. Okay, so here's a problem that is different than all the ones that we've done today. You notice first of all that that leading coefficient is not a one, it's a three.
Uh-huh.
And it's like, well, now what do we do? But it's actually very similar to the last. You take this three and you multiply it by whatever the last number is. 3 times 4 is 12. So now you're
Mhm.
looking for two numbers that multiply to 12, but they have to add to -8. It's kind of a repeat of what we were doing.
Um, okay, so 3 times 4 is 12, and then they have to make -8, so then that would be -2 -6.
-2 -6. Good. So this -8n is going to become -6n -2n. Okay, all I
And
did was
then
split it apart. Is that okay so far?
yeah. So
All
then
right.
is it gonna become -8n, or are we
That
done because then it'll just go
you
back?
you don't want to go backwards. So what you do now is you do what's called GCF factoring in the first two terms. What goes into both 3 and 6? What's the biggest
Uh,
number?
3.
3, and then out of n squared and n to the power of 1, 3n. So you're dividing both of these by 3n. You're finding the GCF of the first two terms. So what
So,
goes in parentheses?
so then that would just be n minus 2,
Good. Now you immediately write what's in parentheses over here off to the side.
and then put the +4 in between them.
Nope, nope. You figure out what goes in here such that when you multiply in, it gives you -2n plus 4.
+2.
Try
No,
again.
-2.
-2. Good. All right. Now, what we've done is called factor by grouping, but it's better represented as double factoring or multiple factoring because you have to keep going here. These both have an n minus 2 in them. So when you factor out the n minus 2, you bring down the non-n minus 2 stuff into the trinomial there.
So you put the inside parentheses together and the outside
Yes.
parentheses together.
If you like that wording, yeah, that worked.
All right.
Okay, we're gonna do
Um,
another. Um, Let me know
is
if you
there an
need to
easy
get
way to determine like when to do what almost? Like so I
yes.
always know to multiply it together when there's a number in front of the N or the X or the A or the B or the
Not
C.
not always. We're not, I mean, I'm not coming at this from like the angle of like you've never seen this before. You actually always start with GCF factoring, but I'm not
Uh-huh.
going to give you any of those today. Well, if you tell me uh that we do a few more examples of these and maybe do some long division.
Yeah, definitely.
So here's another one like the one we just did. Notice that the leading coefficient is not a 1. So you take this time the 2 times the minus 9. 2 times minus 9 is minus 18. So you're now looking for two numbers that multiply to minus 18, but then add to positive 3.
Um, 6 minus 3.
So 6 and minus 3, that worked. So this time we're going to go 2n squared plus 6n minus 3n. Notice 6n minus 3n becomes 3n minus 9. And then just like in the previous problem, you're going to find the GCF of the first two terms here.
2N.
2n. And then on the inside,
That would become N plus 3.
okay, then you immediately write it over here in parentheses.
And it would take positive, no, negative 3 to
Negative
make them
3.
turn into that. And then we'd have
Okay.
N plus 3, parentheses, parentheses again, 2N minus 3.
Okay. So give you a problem to try here. All right. Get as far as you can on this one. Maybe even get it all the way,
All right, we'll
please.
see. Shoot, okay. Can you scroll up to the past problem, please?
Yep.
Thank you. So we get okay, thank you. You can get back down to the bottom. The final answer would be 5N plus 4 and N plus 3.
Like this.
Yes.
All right. So the way you check, or the way I would check here, is I can FOIL this real quick, and it 5n squared, that's for sure. Then it's 15n and 4n, that makes 19n plus the 12. That's perfect. All right, let's try just a slightly more challenging one. Well, actually, none of these are like that. Yeah, let's try one more here. All right, here you go.
Okay, so as my final answer, I have 5x minus 3 and x minus 3.
Okay, that does work. Any questions on that?
Um, no. Honestly, that's pretty clear.
Good. Okay. So there's some other problems that they kind of they appear to fall into this category, but they're not. Let me show you one of those here. Um, this one kind of appears to fall into that category. But one of the things your teacher should have said is that you always try to find the greatest common factor. So in this case, you can divide each of these by 3, 5n squared minus 9n minus 2. Now the part inside here is like the last problem we did, but notice it's a lot better to multiply 5 times negative 2 than 15 times negative 6. So you should always look out for a GCF before you start. Okay.
So look out
Question on that?
for, so look if you can just divide all of it right away.
Right, right. And you've already done a couple like this, so we don't need to do another one. But that's something to be on the lookout for. Another
So,
thing, sorry, question?
so with a GCF, once you divide it and you just have that formula, then do you multiply it?
You don't multiply in because you do this like we did the last problems,
Like the ones like I just last
just like
did.
this. Yeah,
Oh, okay. So just to divide it first.
it makes it simpler. Yeah. Um,
Okay, I'll keep note of that.
so the next thing here is if you want, you can factor this. Up to you. Do you want to factor this one?
Um, I mean, I could probably just do it real quick, verbally. Like that would become minus 10, and then it would be then minus 10 to get to negative 9 would have to be positive 1 minus 9. So then that would be 5n plus 1n minus 10n minus 2. And then, yeah, I can't do all that mentally. I thought I'd be able to. Yeah, we can just go to the next problem though, because I get how it works.
Do you not have some pencil and paper to write with?
No, I got it in front of me. I was just like, oh, I bet I could do it mentally, but
Okay. All right. So here's another problem that has the initial appearance of one like we just did, but you always check for a GCF.
yeah. So then that would just become like n squared plus 3n and 54 minus
Yeah, so
54.
now this one is not like the ones we've done. It was more like the first grouping. I would like you to try this one. Two numbers that multiply to minus 54 but add to positive 3.
All right. Minus 6 plus 9. So n plus 6, n plus 9.
Minus 9. And then you
Minus
bring the
9.
2 down.
And I just keep the 2 out there. I don't do anything with it, right?
Yep, it's floating along. Diddy bopping along, as they say. All right. So that kind of takes care of a few types of factoring. There's a bunch more. Um, but I mean I remember seeing a polynomial division thing with another student. Would you like to spend some time now working on that?
Yeah, I think so. The long division was the
All right,
most
so
confusing.
we'll actually just use this one here. Let's say you wanted to divide this by, well, a couple ways it could be. It's usually written this way. We'll say n plus 6 as an example.
N plus 6.
So you have to remind yourself what goes inside the house and what goes outside the house.
N plus 6 goes out, and that goes in. So yeah, this is the part where I just don't really know what to do because like
Okay,
obviously I
so
understand how division works, but
yeah, so what you're doing is you're trying to figure out what do you multiply n by to get 2n squared. And
um,
and if that's not clear, the other way is to take 2n squared and divide it by n.
and then that would just be 2n.
So that goes here. So then you take this 2n and you multiply it by the n and the 6.
So that would be 2n squared plus 12.
Well then this is very important.
Oh right.
You change the signs.
So why do you change the signs? Is it just because it's like you're subtracting it?
You actually you're always subtracting here, but it's usually easier to change the signs and then add.
Mm-hmm.
Otherwise, you have to remember it's 2n squared minus 2n squared and 6n minus 12n.
All right. So I would only write minus 6n, correct?
Yep, and then you bring down the next term.
And
So then
then
it's the same thing. You take the leading one minus 6n and divide it by n.
so that would be minus 6
Yep,
minus 108. Oh no, so I just keep the minus 6 up there.
yep, minus 6n minus 36. And then you again change the signs.
So oh right, because I'm multiplying the minus 6 into that n plus 6. So then you would get negative 72. So then is that your final answer? 2n minus 6 minus 72?
It depends on how your instructor wants you to write. This is the quotient, this is the remainder, it's the divisor. So you generally write your answer as quotient plus remainder over divisor.
Okay. So it's not too bad.
Nope. Let's try another one here. So we're going to put that x minus 3 outside the house, 5x squared minus 18x plus 9 inside the house.
So then um so am I looking at the
Let's go
I'm
back and look
looking
at what
at
we
the
did in the previous
18,
problem.
correct? Like I'm looking at the second part first.
Well, you're trying to get to 5x squared from x, and you could divide 5x squared by x.
So okay, so 5x squared by x, so then you just get 5x,
Okay, so that's what goes there
and then
above
you'd
the minus.
multiply it, so then it's
And it's
5x minus 15x.
yeah, it's important that you put it in the right place. Then you have to change the signs or subtract depending on how you look at it.
So then that would just become negative 3x plus 9. And then I'm going to multiply minus 3 by x minus 3. So then that would be minus 3x plus 9. Oh, wait, no. Yes, right?
Yep, and then you change the signs. So sometimes it does equal 0.
Does equal 0. And it would just be plus 0 in this scenario.
Yeah. Now, I'm going to give you a slightly more difficult one to try. These are not like the ones you typically see on the test. Um,
Oh,
okay, so here is one that you would probably see. Let me make sure, see if it works out of that. It's okay. All right, yeah, so give this one a try. I need to step away for like 30 seconds, but I'll be right back with you.
sounds good.
All right, I am back.
All right.
What have you done? What have you been able to do here in this problem?
I wrote out the formula and then I realized I'm not. I was gonna just do what I did before, but then the numbers just kind of like confuse me because it's not the same. I guess not much besides the.
If you're ever not sure where to start, you take the leading thing here, n cubed, and divide it by n, or whatever it is, whatever the leading
Okay.
ones are.
So I guess just n squared plus
So n
no,
squared goes in the n squared column.
and then I multiply n squared by n plus two.
Yep,
So then that would be n cubed plus n two
2n
squared.
squared.
So then
Then
that
you
would
change
become
the signs.
minus minus. So then that would become 5n squared. You put it up there. So then it's n squared plus 5n squared at the top
Nope, no. You now take the leading one,
and multiply it by n plus
divide
2.
it divide it by n. No,
So then that
you're
would
trying to
be,
figure out what,
oh, sorry.
like, focus on where the positions, they're the leading positions here. This divided by this, n cubed
Oh,
divided by n. And then you grab the next leading one, 5n squared divided by n, and you put the result up here. So what's 5n squared divided by n?
just 5n.
Okay, so that's and then you multiply by n plus 2.
Then multiply it by n plus 2. Um, Wait, sorry. So you put it up there, and then
Well, what did we
I
do
don't know
with
what
the n
to do.
squared? What
So
did
n
we do with n
squared.
squared?
Uh, Bring it down.
Let's go back to previous problem. What did we do with the 5x?
Multiplied it with the original formula.
Okay. Then what did we do with the minus 3?
Multiplied it with the original formula.
Okay, so what did you do with the n squared? You multiplied it by n plus 2.
N plus 2. So now we're
So what
gonna
are
do
you
that
gonna do?
with 5n's.
Yes.
And we're doing it with 5n and not 5n squared, correct?
Yes, but I'm not sure what whatever is up here is what's called the quotient is what you multiply by. You're trying to figure out what you multiply n by to get 5n squared so that you can get rid of it.
Uh-huh. So
5n times n becomes 5n squared. You always cancel the leading coefficient.
uh-huh. So is it 5n squared plus 10?
Close.
Oh, n plus 10n.
Okay. Then you subtract or change the signs.
So then it would be 4n plus 3
Okay. So now you're trying to figure out what goes up here in the top right. You can always take the leading thing and divide it by that. You can go, 4n. If you're not sure what it is, it's 4n over n, which is 4.
plus 4. Okay. I'm gonna have to practice that one for sure.
Well, we're not done. Keep going here. You got to take that
Oh,
4 and
shit, it's
multiply
still
it by.
going on. Okay, so now I'm gonna multiply uh 4 n into n plus no 4 into n plus 2. So then I
Okay.
get 4n plus 8. No, it would be minus 4n minus 8.
Change the signs. Yeah. And then
And then that would
what's
be
left over
negative
is,
5
yeah. That's your quotient. Down there's your remainder. That's your divisor. So the answer is written as the quotient plus the remainder over the divisor. Uh, I grabbed this from a worksheet. I don't make these up. Um, but it looks like this when you're all done. This is the quotient. That's what you
Mhm.
had up here at the top. The remainder is minus 5. and then the divisor is that thing you put out in front.
Okay. All right. Wow. So that's, I
Right.
guess, gonna be the hardest, just because there's so many little steps to remember, I guess.
Yeah, yeah. Okay, let's just stop here for today.
Yeah.
Stop there.